Good morning, dear students. Today I am going to discuss how we will be determining the sample size. Determining the sample size is very important because all of our research is dependent on this. That how much sample, how big or small your sample is, right? So let us see sample, what sample is, though we have done it, but still it is the specific group of individuals from which you will be collecting the data. It is actually a part of population, subset of population, which is going to be part of the survey, you can say, or your research study. And sample size, the number of individuals you should include in your sample depends on various factors. How would you decide the size of sample? Till now we have studied how to decide target population. That was our first step. Then second step was deciding the sampling frame. Third step was deciding the sampling method, sample design. Now after deciding that which sample design we are going to use, we need to decide how much what should be the size of sample so as to get accurate result and so as to get work done in limited budget if you have, right? So this depends on so many factors. Number one, size and variability of population. What is the actual size of the population and how does it vary? And that has to be seen as per the target population you already have. Then research design, what kind of research design you are going to use for your study, whether it is exploratory, descriptive, causal, or then what is the sampling design. Both of the things are would make a lot of contribution while deciding sample size. Then resources available to you. Resources here are people available to you who will be interviewing the people, or maybe the time available, budget available, and some resources, like if you are going to go for telephonical call or something like that, whether the list of target population is available or not. These all would fall under the category of resources. The list available of target population, or you can say a number of population in exact, or maybe time available to you, maybe the budget available to you, and the labor available as per the area of your target population. Labor here is basically the interviewers and some local people who are going to help interviewer in case of language problems. Then purpose of research. If your purpose of research is just academic, or say for completing your master thesis, then you might not think much about sample size. You can go for little smaller sample size. But when your purpose of research is actually something to be applicable in real life, then you have to define it very carefully. It should not be too big or too large in that case. Then how big should the sample be? Researcher wishes to examine every potential buyer of a product, every employee, or every stock traded on an exchange, but it is actually not possible. Can you actually go to every person of your target population? No, it is not possible. Sometimes when your target population is very small, maybe 50 people, 100 people, you might go and talk to them. You might go and explore the views they share on one particular idea, right? But when you talk about potential buyers of a company, or all the employees of company, every stock traded on exchange, it is not 100% feasible to go for interviewing the target population. You should always go with some sampling, and there are so many reasons for that. Sometimes everyone is not available to you. That is why we go for sample, though we have discussed in it this thing in first video of unit 3. You can go back and check the video if you have any doubts regarding why to choose a sample from the population. But this is also one of the major example. Like, you cannot go and talk to every person. You cannot go and get your questionnaire filled from every person in target population all the time. So that is why we go for a sample. But typically we say that large samples are more precise than small samples in most of the cases, but still we should go for smaller samples as much as possible, because when you go for smaller samples, it's easy to conduct the survey, right? But when we go for larger samples, we will be able to get very much accurate, undistorted results. That's true. But still, if you go for extra large samples, then it might distort the results up to that extent that it was that smaller sample was better than this extra large sample. So it should be appropriate, neither too large nor too small. Proper probability sampling is implemented, and a small portion of total population will give a reliable measure of the whole. For example, you have 1,000 people in your as part of your target population. If you go and interview just 10 people, it will not make any sense. It will not give you the accurate results of that particular study. But you should at least select 100 people out of 1,000, at least 10% of that population, right? But when we go for population which are actually in lakhs, then you might go and choose just 1,000 people out of 1 lakh people, and that is just 1% of the whole population. So it's not like that you should actually go and choose just 1%. No, it depends on so many things. There are formulations as well. On the basis of those formulas also, we'll be deciding the exact sample size. So it is not just the percentage. There are so many things involved, and these by applying all the combinations of these things, we get exact measure of sample size, and then we can go with that particular sample size, or you can alter it up to a bit as per the errors you can allow in your research study. What does statistic mean? When we talk about statistics, there are two kinds of statistics. One is descriptive statistic. Descriptive statistic means, for example, you will be describing the data in a way like number of people involved in the study, or maybe trends of employment is like this, or maybe you will be showing the data in tabulated form. This is actually describing the data. Descriptive statistics. When we talk about mean, median, mode, this is all about descriptive statistics. But when we actually explain the data by taking out something from it, for example, we try to make some conclusions out of it. That is inferential statistics, which makes an inference about a population from a sample. When you try to give some judgment on the basis of data collected from the sample for the whole population, that is inferential statistics. Descriptive is just describing the data, describing a few things. But in case of inferential statistics, you are going to actually make some inferences about the whole population. Population parameter versus sample statistics. We have got two things here, population and sample. When we talk about population, we always say population parameters. But when we talk about sample, we will say sample statistics. Throughout the unit, you will be using these two terms. Let us discuss them. Population parameter means variables in a population is also a part of population parameter. Then measured characteristics of a population, those are also parameters of population. Then for this population parameter, we calculate population mean as in this way. Mu, this notation is actually Greek notation, and it is called as mu, and that is equal to summation of all the observations you have divided by total number in population, total number of people in population. So mu is equal to summation of all the observations divided by number of people in the whole population. This is little different from the sample statistic. We will just see it. Sample statistics means variables in sample, then measured data from computer data, right? And its notation is basically X bar. X bar basically is average of X, you can say, right? We call it generally an average, but here we'll be calling it as sample mean. As the name suggests, mean, average, mean, and this is sample mean, that is equal to observation of all the participants divided by number of participants available in sample. Here we are dividing this by number of people in sample, and in case of population mean, we were dividing the same observation by number of people available in population. So this is the difference between these two. Then there are terms, for example, population distribution, sample distribution, and sampling distribution. These are very important while deciding the sample size. This is how we'll be we'll be describing them with the help of symbols. These are the symbols used. When it comes to population, mu is the notation used for population mean, and for standard deviation, we use standard deviation, right? So, and in the case of sample, we will be using X bar, that is for generally used for average normally as well. This is for sample mean, and this the letter S for standard deviation of sample. Then for sampling, we will be using mu, which was used for population mean, mu of X bar, mu of sample mean. Mu of sample mean is considered as sampling mean. And then again, alphabet S on X bar. That means standard deviation on the basis of sample mean would be taken as sampling standard deviation. So both these terms are related to X bar. Matlab, you will be calculating sampling distribution mean as well as standard deviation on the basis of sample mean. Then this is the curve. Generally, we call this curve as normal distribution curve as well. This is actually the mirror image, right? You can see over here and over this side, on both the sides, image is actually like a mirror image, right? So this is your normal curve. We generally say that as we increase the sample size, this curve tends to be more normal. That is why we initially said that samples should be little larger than normal. If your sample size is large, then the curve tends to be normal, and it shows that your data is normal and you have collected the data well and everything like that. When it comes to population distribution, this is how we'll be showing the distribution. This is the mean in between all the entries, and this is the variation we accept. We call it as standard deviation, but still we will be accepting this much of variation in our results. So that is why this gap is there on both the sides. Plus minus, this variation is allowed in the population distribution. And the same way, there is sample distribution. For sample distribution, you use the term X bar, and again, similarly, the same standard deviation is allowed here also with the help of the sign standard deviation. Again, the sampling distribution, this is mean for sampling distribution, and this is allowed, like this plus minus S on X bar is allowed. This deviation is generally allowed in all the things. This is even known as sometimes plus minus error term. We will calculate all these things in the last. Then standard deviation of the mean. How would you calculate, standard error of the mean. How would you calculate standard error when it comes to mean? By calculating standard deviation first. Standard deviation on X bar, that is basically your standard deviation for sampling distribution, right? We discussed in just a few in last slide that S on X bar is your standard deviation on sampling distribution, and it is calculated as standard deviation of population divided by under root of total people in, or say total units in sample. Small n is donated for sample, and capital N is donated for population. Parameter estimates, these are basically the point estimates, and confidence interval estimates. How would you calculate these? Actually, these are the confidence intervals we take in our study. Then yes, some formula related to the confidence interval. How would you calculate it? Mu is equal to x bar plus minus some small sampling error, and this error is actually calculated by ZCL into S on X bar, right? ZCL can be taken from the table at the end of your notebooks, at the end of your textbooks available to you. You can pick any book on research methodology, and these tables are given there. And on the basis of the numbering, you on the basis of the error you have allowed in the study, and then S on X bar, standard deviation of sample mean, is being calculated. We have discussed the formula. So mu basically here is equal to X bar plus minus error, and this error is equal to this. So we can write it in this way as well. S on X bar is calculated in this way. So we will be introducing the formula of S on X bar also in the formula in this way. So the whole equation now is mu is equal to X bar plus minus ZCL into S divided by under root of n. This is being derived from this particular formula. First, we introduce the formula mu is equal to X bar. We have discussed it even initially, plus minus small error, and this errors formula has been replaced here. Like when we said that this is the formula for mu, this small error has been replaced by this, and this formula is also being replaced in another slide. Mu is equal to X bar plus minus ZCL S on X bar. This is the same here, and S on X bar is also being replaced here. So this is the final formula. Mu is equal to X bar plus minus ZCL into S divided by square root of n. So this is the final formula with the help of which we will be calculating the values of sample size. Then random sampling error and sample size are also related. How they are related? We talk about sampling errors generally. These are basically related to sampling technique, right? And these are up to some extent related to sample size as well. If your sample size is too small for the sampling design technique, that is a kind of problem. Generally, problems arise due to smaller sample size rather than larger sample size. When your sample size is large, it is considered that you will be facing least or minimized problems, at least due to sample size. Sample size is dependent on three major things, and these things are variance, standard deviation, you can call, then magnitude of the error. The error you allow in your analysis, you can allow in your analysis, and then confidence interval. This is also related to the error up to some point. So calculation of sample size basically is n is equal to ZS divided by E and the whole square. And this formula is being derived from this particular equation, this equation here. Let us discuss it with the help of an example. Suppose a survey researcher studying expenditures on lipstick wishes to have a 95% confidence interval and a range of error of less than $2. The estimate of the standard deviation is $29. So all the values are given to us. When we say that n is equal to ZS divided by E raised to the power 2, then Z is available here. Z is 95 confidence interval. You can check the value of Z at 95% interval. It is 1.96. Basically, we go with three interval levels, three confidence levels. One is 90%, then 95%, and then 99%. 95% confidence level is the level which is maximum used by the researchers. 99% level is used by medical practitioners where maximum accuracy is required. And 90% is used in those studies where you just have to settle some things. You need to, when you are not going to apply those things in real life situations, you are just trying to study something on the initial level. You will be studying them again with some larger sample size. At that time we can allow 90% confidence interval, but maximum studies take 95% confidence interval. 95% confidence interval means you have allowed almost 5% of error in the study. And range of error means 2, errors value here is 2, and standard deviation is 29, s value is 29. You will be putting all the values in the formula and you can get the value as 808 as your sample size. Let us take one more example. If error acceptable here is 4 rather than 2, then you will be changing just this value in the whole formula. And let us see what happens. When you allow little more error, then your sample size is reduced to 202. That means when you allow little less error, you have to go for larger sample size. And when you allow little more error in the sample, then you can go with little smaller sample size. I think this explains very beautifully that you should always go for little large sample size, at least as per the target population. But sample size should not be that large that it might cost you more than the actual results. This is also one more calculation of sample size. If we go with 99% confidence interval, at 99% confidence interval, Z's value is 2.57. Other things are same in the equation. And you can see that when confidence interval increases, your sample size also increases. Over here, sample size was 808 when it was like 2% error was introduced and 95% confidence interval was there. But here it is 1389. You are basically trying to say that you are 99% confidence about the sample size results, right? So you have to go with little larger sample size then. And in case of 4% error as well, it was 202 as your sample size, and here it is increased to 347. So I hope it is clear about a confidence interval as well, and the error estimated in the count. Then standard error of the proportion. Sometimes we go with this also. Standard error basically is PQ divided by N, the whole square root. P here is basically probability of happening something positive, probability of acceptance, and Q here is probability of rejection. So you can quote Q as 1 minus P as well. This is another formula. You can use this also. This is all the same. Let us discuss this also with the help of some example. These are the alternated formulas. We are just trying to replace the value of S by PQ. That's it. Nothing else has been done. You can see that P plus minus ZCL SP. We have replaced this with the value of PQ now. And this is basically N is equal to Z square PQ divided by E square. We can demonstrate this in a way like N is number of items in the sample. As I already told you, smaller N is for number of items, number of people in sample, and smaller and capital N is for number of items in population. Z square is the square of the confidence interval in standard error units. Then P is estimated proportion of success of something, success or acceptance, you can say. Sometimes we use synonyms while quoting the value for this P. Q here is estimated the proportion of failures. Of course, if success means 4% or say 40%, 60% goes with the failure, because in probability what we do is P plus Q is always equal to 1. Success plus failure would be 1. This is how we go with probabilities. E square is the square of the maximum allowance for error between the true proportion and sample proportion, or ZSP square. Z here is confidence interval and SP here is standard deviation of success. This way, you are just going, when you have given the value of P and Q, P means 0.6 and Q means 0.4, and you have been told that you will be calculating this at 95% confidence interval. Then we'll be checking the value of Z at 95. We have already used the value 1.96. 0.6 is also given, 0.4 is also given, every value is given, and you will be just putting the values in the formula and calculating the sample size. Sample size here is 753 in this particular case. That's it. Let us discuss some true false. Number 1, the primary purpose of inferential statistics is to make judgment about a population. Is it? Yes, we generally actually make judgment about people when it comes to inferential statistics. Yes, it is true. Second, population parameters are computed from same sample. Is it from sample data? Population parameters are generally computed from the data available for population. Population parameters are measured characteristics of a specific phenomena, specific population. So it is not computed from sample data. So it is false. Common practice in research is to use the 75% confidence interval about the mean in research studies. Is it? No, we use 95% confidence interval. So it is false. Fourth is, a researcher must calculate the sample mean to calculate the confidence intervals. Is it? Yes, we generally calculate sample mean first and then we go with calculating other things. The confidence interval increases as the sample size n increases. Is it so? Confidence and interval actually decreases as the sample size increases. So it is false. Then increases in sample size reduce sampling error at a decreasing rate. Yes, it reduces sampling error, and that too at just decreasing rate, not more than that. So it is true. Seventh is, 3 factors are required to specify sample size, and these are the variance of the population mean, and confidence interval. Is it? No, the variance of population is okay. Confidence interval is also required, that's true, but instead of population mean, we go with the magnitude of acceptable error. So it is false. Last, in most cases, the size of population does not have a major effect on the sample size. Yes, we do not calculate sample size just on the basis of size of population. There are so many other things we include while calculating the sample size. And some self-assessment questions. Number 1, what is the difference between descriptive and inferential statistics? You can define them. Descriptive is basically to describe the data, and inferential is to make some inferences about the data. Then discuss the 3 factors required to specify the sample size. We just discussed them, these 3 factors in the last. The variance of the population, magnitude of the error, and the confidence interval. Just mention them and define them one by one. Then what is the sampling distribution? How does it differ from the sample distribution? Yes, this is a good question. Sampling distribution is a theoretical probability distribution that shows the function relationship between the possible values of some summary characteristics, such as mean of n cases drawn at random and probability associated with each value overall possible. Sample of size n from a particular population, but its distribution of x bar is generally taken as in to calculate the sampling distribution. The sample distribution basically is the frequency distribution of just x from the actual sample drawn. So this is the basic difference. When we talk about sample distribution, we try to talk about just x, actual observations from the data, and when we talk about sampling distribution, we talk about x bar, average of all the observations. Next, what would happen to the sampling distribution of the mean if we increase the sample size from this to this? What would happen? The sampling distribution would have less dispersion. An extended example of the sampling distribution of the mean is like it shows the distribution of mean of 20 samples of sample sizes and of 5 and 25 respectively. then you can actually calculate all the dispersion levels and all that, and you will be able to find out that as the sample size varies, your dispersion would vary, and from 5 to 25 dispersion is going to decrease. Then using the formula, that means your sample size is being corrected as it increases. Then last is using the formulas discussed in this chapter. Researcher determines that at 95% confidence level, a sample a sample of 2500 staff is required to satisfy a client's requirements. The sample the researcher actually uses is 1200 because the client has specified a budget cap for the survey. What are the ethical considerations in this situation? It is commonly done in business research to be conducted with sample sizes that then are less than ideal, but it depends whether you have conducted the survey well or not. So it is not a big problem. People generally do that when you go for research surveys through agencies. But tolerance of error should be taken care of here so as to get the required results. That's it. Thank you. In our next video, we will discuss measurements and scaling concepts.